we did already. I made a handout for note-taking purposes, so we can go a little faster. We don't have to copy down diagrams and whatnot. So anyways, given that DEFG is a parallelogram, very important to us, a parallelogram, right? It's a slanted rectangle, sorry, where we know that these two would be parallel to these two. And in fact, every line on this parallelogram is also a transversal. You're like, what? Right? Because every line cuts through two other lines, right? So every single one can be treated as a transversal. So that's kind of unique about a parallelogram. So in fact, a lot of the questions on this page and the following deal with parallelograms. It's actually easier to deal with them, believe it or not. So angle D, I'm going to start with, I'm going to start with it. That's the first one I'm going to do. And I noticed that these two are parallel and it's connected by this transversal. And there's something I know about these two angles. When the lines that are connected are parallel, first of all, I know that they would add up to 180, right? So that gives me 73. degrees, and I say that consecutive interior angles equal to 180. So I went from here to there. I can write in the 73 if I wanted to, and make sure I stated here on the chart, on the table, that that's what I just found. So justification and work, perfect. You get full marks there. DGF, I gotta go find, right? So you start there, DGF. It's when you connect those 3 points, the angle is formed always in the middle. So that letter G is where the focus is on. So this one right here is called lowercase m. Okay. How would you find that? This transversal connects two lines that are parallel. So these are also consecutive interior because the two lines connected are parallel. Okay, does that make sense? Okay, so I gotta go 180 minus 73, which gives me 107, sorry. Consecutive interior angles. So it's actually easier, as you can tell. You can transfer sideways too, which you cannot do if these two lines had not been parallel. Okay, you can only do that because of it being parallel this way as well. So 107 it is. Okay. The next angle is EFG. So EFG, it's right here, and that is just N. Okay. And I will just do the same thing. I'm going to go this way. I know that these should also be consecutive interior. So this is 107 here. And I'm suspecting that this will be 73 as well here. Consecutive interior, watch this, angle to angle M. So I'm going to make reference that it's consecutive interior to M, right? So this is consecutive interior to that one. So I'm just going to go 180 minus 73. You get the hang of it, right? Sorry, 107. Take the 107 away from 180 to get 73, right? And so we've kind of went all around full circle to get this, right? And then it's asking for angle GFH. GFH is right there. We're going to call that lowercase p. And then FHG, FHG, this one right here is what we call Q, okay? Lowercase. All right, so let's do this one first. you notice that there's a straight line here, so we can use straight angle property. You might be tempted, right? Or you might also see what else can you use. What are these two called? Alternate interior, right? So I'm going to use alternate interior here. I'm just going to say that it's 107. Alternate interior angles are congruent, right? I kind of sometimes, some students like this, like I went there, then I went there, then I went there, right? This gave me that one, right? So they like some arrows to tell a story. That works as well. And then now we need to deal with Q here. And I don't know if you noticed, but this introduces an isosceles triangle. I don't know if you've noticed that. And let me tell you this, if you know one angle in an isosceles triangle, you can find them all. All you need is one angle, you can find the rest. And I'll use that quite extensively today. So let's just make sure this is 107 here. So to find Q, watch what I'm going to do. To find Q, I'm going to go 180 minus the 107, this one here that I know, because these two sides share the same angle, like they're the angle opposite, right? If I go from this side to there or this side to there, they share the same side. So I'm going to take the 107 away that I just found there, and I'm going to divide that in half. Okay, so that gives me 73, and I divide that in half, and that would be 36.5 degrees. And for justification purposes, I'll just say sum of triangles 180. That's really the property that I've used for that one. Okay. And let's do one more. So when I give you a handout today, we're going to write at the top of that, see page 20 first, okay, in this booklet, and then we'll go back to that. Next. So there's a parallelogram, and it's JHIK is a parallelogram, so I know this. Okay. I can put the markings down. Let me just zoom out a bit. Okay. Because of this word, I can assume that this is true. And let's put some letters in there. How about we go X, Y, Z, and then we go M, N. Take a moment to at least find X, Y, Z. The rest I will help you with. Put X where it's supposed to go, Y where it's supposed to go, and so forth. You can do it. And if you're really feeling it, then you just go and find M and N as well. I'm just going to silently put the letters up here. Oh, sorry, I got the X wrong. That's why you need to be careful. This is x right here. And hij, this here is actually m. HIK is going to be tricky because it's the whole thing here. So let's just, instead of putting a letter there, I think we can just leave it like this, like don't put a letter in there because it will make it too messy. Right? So I'm just going to go, I'm going to stick with it, but I know that it's this whole thing, right? It's going to be m plus 86 degrees essentially. Right? That's what it's going to be. All right, so let's get started. I look at my diagram here. And what could I start with? Is this one of those that I forgot to give you enough information for? 55, okay. Where would you start? I found it just now. I had a little bit of a moment here. But what I'm going to use is these are two parallel lines here. I'm going to highlight them like this, right? And there's a transversal that connects them, right? This is right now a transversal that connects them. So these two angles, like this big angle and this big angle, should add up to 180 degrees because they're consecutive interior. Okay, like 55, M, and 86, all those should add up to 180. Okay, so I know that I'm going to solve for M first here. So I'm going to go, this is my starting point here. Okay, so I'm going to go 180 minus 55 minus 86. So I'm going to take the 55 and the 86 away, and that's going to leave me with M. Okay. And because it's Monday, I will make sure I use my calculator. So that's 39 degrees. And I will say that it's consecutive interior angles add up to 180 degrees. That's my justification there. Let me just bring this up a bit. So 39 degrees it is. Maybe it's a good idea to write that in, right? That this is 39. So you have more information. And now it should be a lot easier. So the start was a little challenging, right? So I'm looking at this parallel line being connected to this parallel line by this transversal here. So M and Y would be considered alternate, right? This is your transversal, alternate interior. So I'm going to do that second here. Because I'm a little bit all over the place, I'm just going to say that that's 39 and just say alternate interior angles are congruent. Okay. Some of you probably saw a different start. I can see it now. The 86, right? These are two parallel lines connected by that transversal. So this actually comes in here as well. You can go sideways because those are parallel. Okay. So the 86, so X, which is right here, that's my third move, is 86 degrees. And I will just use alternate interior angles are congruent property as well. And I will make this M, I will make it travel that way. So it's connecting these two lines, and it's also connecting these two lines. Z, I can use a sum of triangles, right? Because if I know that this is 39 here, I have 2 out of the 3, so I'm going to use that one there. 180 minus Y minus 86. 180 minus 39 minus 86. That is 55, which I could have 55. And I use sum of triangles equal to 180. I use it there. So this is 55. And then HIK, now I'm ready for it. I'm going to just take the 39. I'm going to add the 39 and the 86 together. So let's make sure we put a 4 here. That's my fourth step, and then this is my last step. And that's the way I did it, not necessarily how you would do it, right? So we have 95 plus 30, that's 125 degrees. No property there, you would just do that. So parallelograms are in that sense easier because you can go sideways. If these had not been parallel, you cannot use alternate interior between these two. Like the 86 would not have transferred over to the x. Okay. Okay. I will give you a handout now. Top of the handout, say do page 20 in workbook first. And that is parallelograms, right? Because I didn't give you any parallelograms examples, so I just wanted to make sure you had that there. Okay. So let's see how you would do something like this, okay? If it asks you to determine the values of x, you're going to get something like this, so you just need to make sure you work it up accordingly, okay? So when you are asked to find x here, don't worry about AB just yet. You first focus on these ones. And what are these two angles called? Not all at once. What are those two angles called? Alternate interior, yeah? Okay. Yes. If that's what you were saying, it's alternate interior. And what do we know about alternate interior? We know that if these lines are parallel, we know that they are congruent. So this is actually this is the easiest case. This is the one you would like to get, okay? If you had a choice. So 7x plus 28, that angle is going to be exactly the same as 2x plus 78, like that. And then you just solve for x. It's always solve for x, but it's important to set it up, right? And so I'm going to bring it over the 2x. And on the other side, I bring over the 28, subtracting, so they both subtract when they come over. That's 5x over 50. Nice and easy, right? X is equal to 10 degrees, that is actually. So you solve for x there. And if you notice, A is vertically opposite to this one, right? So angle A is actually 2x plus 78. Right? So angle A is 2 times 10 plus 78. Angle A is 98 degrees. Angle B, there's a couple of ways of doing angle B here. You can just say that angle B is 180 degrees minus 7x plus 28. And watch this, you have to make sure you put your brackets there. right? Because B is along the straight line here with this other angle. So I'm just going to subtract this one from 180. So I go 180 minus 7x plus 28. And the nice thing is you can just plug in without having to worry about much there. And so angle B is 180 minus, this is also 98, right? Oops, sorry. So that's 82. So there you've solved for x, you've solved for the two angles that they were asking you for. I hope I left you enough room there. Next, what would you do there if you had to solve for x? What would you identify as your first step? Do you see the triangle? You see this triangle here? Now you see it, right? And so you identify that, right? These three angles here must add up to 180, okay? So I'm going to use the sum of triangles equal to 180 to get me started there. And so we're going to go x minus 12, right? I put that in brackets, plus 2x, plus 5x. All of that adds up to 180. So you're basically, there's not a one size fits all. You have to watch out how are those angles that have the variable x in them related. And in this case, I know that all three add up to 180. So x, 2x, and 5x add up to 8x, okay? And I will just bring down the negative 12. I'll actually show that step there is equal to 180 degrees. And I'm going to bring the 12 over. 8x is equal to 192. Divide everything by 8. And that is 16, 32, 14. Sorry, 24. What am I saying? 14. X is equal to 24 degrees. So you found x there. And in this case, I will just actually plug in, right? 5 times x, so 5 times 18. I will just cut this here. 5x would be 90. It's obviously not drawn to scale. 2x would be 36. And 18 minus 12 is 6. That doesn't make sense. Did I make a mistake? That does not make sense. Oh, where did I get the 18 from? Sorry. Do you see the mistake? Yeah, my bad. Sorry, guys. It didn't add up to 180, so it just doesn't make sense. Let's try this again. 5 times 24, that makes more sense. That's 120 degrees. 2 times 24, that's 48 degrees. Now we're talking 24 minus 12, that's 12 degrees. So this is 60 and 120, 180. So that all checks out. Let's go ahead and just write them in, okay? So this is 12 degrees, even though it doesn't make a whole lot of sense because it's not drawn to scale, right? But in that case, you just enter those values there. And this is just my check here on the side to figure out what those are. And to find angle A, for instance, here, angle A would be 180 minus 48, right? They're along a straight line here. So if I just go 180 minus 48, I get that. So that would be 132. Right? And I use straight line, right? Property, I'm not going to do that right now. Angle D, this one and this one are called what? Start with a C. Corresponding, right? So D is corresponding, which is the same. Because of these lines being parallel, I can just say that A and D will be the same. Corresponding. Okay, so I got that. C, angle C is the same. These two are the same. So I'll just make that 120 and I'll call that alternate interior. Okay, because I don't have a lot of room, I'm just going to do it that way. B is vertically opposite, so angle B is 120. I'm going to use the vertically opposite. You could also say that it's corresponding here, but I'm going to use vertically opposite there. And so I've solved for X, I've solved for A, B, C, and D. I need to go back and make sure that this is not 120. It doesn't make sense, right? That this is 120 degrees, but we'll just stick with it, stick with the plan. I will make sure that it works out next time. Okay. Let's do one more. Okay, my time here. So this one is the most challenging one that I would say you could get. One of the most challenging ones. Okay? And this is why. When students look at these two angles, this one and this one, there's no name for them. Right? Like you don't have a name, you don't know how to relate them. So this is my trick, okay? No name for pair. And here I'm only going to solve for X. Okay, I'm not going to solve the rest because you know how to do it by now. So find a pair. What I'm going to do is I'm going to figure out this one, and then I know that these are corresponding. So this angle here, watch carefully, is going to be 180 minus this angle right here, which is right now, all we know is it's 3x plus 4. Does that make sense, that little move there? If this is 3x plus 4, then this angle is 180 minus 3x plus 4. And for these two, you do have a name now. Okay. And I know that corresponding angles are congruent. We know that because the lines are parallel, right? If the lines are parallel, those four things are always true. And one of the things that we're looking at is corresponding angles. So now I can say that 5x plus 40, it doesn't matter which one you start with, to be honest, is going to be equal to this other angle I just found, which has this weird way of being represented, right? But it's okay, we'll work with it. I need to clean this other side up a little bit. So I will deal with that negative. I will highlight that negative because that is very important. It's actually mine -1. So 5x plus 40 is equal to 180 minus, and you're going to distribute that negative, however many terms are in that bracket, you got to distribute it among all of them. So that's -3x minus 4, right? It basically essentially changes the sign of everything inside that bracket. So it's negative and negative. Now you can bring stuff over as you like. So I'm going to bring all the x's over. So 5x is already here. I'm going to bring this 3x over adding. And I'm going to bring all the numbers. The 40 comes over subtracting. And the 4 was already there. So I'm just going to leave it there. Tag along like that. That's 8x is equal to 136. Divide both by 8. And that is 17. Most of the time, it'll be a nice round number. Most of the time, not always. So this one was a bit more challenging because we had to find, somehow had to find an angle where you get that, right? Mr. Dixon, could I have found this one and then used alternate exterior? Yes, but it would have been the same final answer because it's still 180 minus this to get that one. And then you have vertically opposite, alternate exterior angles, right, that are here. So we're just going to leave it at that. We're not going to find A and B or C. We're just going to leave it for there. Okay. Now, I want to review what we talked about on Thursday. Leave this one for now, right? Just leave that one for now. Page 9, don't worry about it. Go to page 10. I'm going to probably assign page 9 to you. Page 10 says types of triangles. The one in particular is the one that uses up the most room right now in the middle. That's the one I want to focus on, okay? But scalene triangle, all angles are different, and therefore all sides are different. That is a fact. You can just look at the angles of a triangle. If they are different, then you know that all sides are going to be different, and vice versa. Okay, it goes both ways. It's an if and only if statement, actually. Isosceles, it has two congruent sides and therefore two congruent angles. I could have started with angles and then said sides. It doesn't matter, but that is a fact, right? Equilateral, all angles are congruent. Let's just do that. All sides are congruent. It doesn't matter how big the triangle is. The fact remains that it will always be 60, 60, and 60 because you're splitting the 180 degrees evenly among three angles. So whether you have a small equilateral or a big equilateral triangle, it's always 60 degrees at every angle. So let's focus our attention to the isosceles. Notice what I wrote down. If you have one known angle, you can find the rest. That is very important because sometimes you're going to feel like you're stuck, but you actually, all you need is one angle and those markings, and you're in business, okay? I'm going to use a red pen for this part just to insert that 72. So if these two sides are the same, right, and you make that connection, okay, this side is the same and it has a 72 there, then you automatically will take the other congruent side, because keep in mind this could be sideways, this triangle. So look at the markings and you assume that the angle across the other congruent side is going to be the same as the one you already know. Right? So here, angle Y is going to be 180 minus 2 times 72 degrees. You could go minus 72 minus 72, it's the same thing. That would be 144, right? So the top angle gets you at 36. So that's how you would do a question like that. You give one angle, you found, yeah. Go ahead. And then the next one, 50 is here, right? So notice this, very important distinction. This side and this side, they're both going to have the same angle across from them. So the 50 we cannot transfer just like we did before. We can't just say, oh, that's 50, so the other one is 50, because 50 doesn't have the congruent side across from it. So watch what I'm going to do here. I'm just going to call this, because they're both the same, I can call this A and A if I wanted to. Like they're both measure the same, so I just need one letter. So to find angle A, all I'm going to do is I'm going to take 180 degrees, subtract the 50 from it, and divide that by 2, right? Because you're basically taking this from 180 away, and you split the difference in half and spreading it out evenly among the other ones. So 130 divided by 2, that's 65, right? So you actually now know all three angles, right? 65, 65, 50. There we go. So these two formulas, so to speak, right, are very handy to find everything else, because sometimes parallel lines are going to have a triangle in there where you can recognize these markings, right? Like this is what is important to know which two angles are the same here. Which ones are they? Is it the one, am I going to be able to just take the 72 that I'm given and put it somewhere else as well? Or are they giving me the one that is not the same as the other two, right? So your two scenarios there. Some review stuff, I know. I just wanted it to be on here. Polygon, we talked about regular versus irregular, convex versus concave, right? Concave has the reflex angle bigger than 180. Not extremely crucial for you to know, but we will deal most likely with convex most of the time. A regular polygon, let's review that. All sides are congruent and all angles are congruent. That is the definition of the word regular. Tells you that. It guarantees you that all angles on all sides will be the same. And irregular, it's basically some angles may be congruent and some sides may be congruent. Okay, so it's the may. You might have a few that are, but as soon as one of them isn't, we're back. It's irregular. Okay, for something to be regular, these two conditions have to be met. So the first couple of regular polygons would be your equilateral triangle, your square, right? Your square, and so forth. If it's isosceles, not regular, okay? And obviously this one doesn't look regular at all. The rectangle has, right, two pairs of sides that are the same. All angles are 90, by the way. Okay, rectangle has all angles the same, but it doesn't have all sides the same, so it still does not fit the regular category. Let's keep going. To the top of page 11, all polygons have an interior and an exterior E is so the I and the E, right? Interior exterior angles, interior exterior are supplementary. They have a sum of 180. Notice this, and I know you have this in your notes, but it's been a couple of days. Sum of exterior angles is always 360, regardless of irregular or regular, and regardless of the number of sides. That's kind of odd, right? It doesn't matter how many sides the polygon has. If you were to add up the exterior angles, it's always 360. Let's identify one exterior angle. So if we look at this and I ask you label one exterior angle, pick any side you want. Like let's say you want to pick this side, travel along it till you get to the corner and just extend it. And the angle between that extension and the side like this, that's called the exterior angle right there. And right next to that exterior angle, completing that, is your interior right there. Okay. So you can clearly tell that they're supplementary. So exterior plus interior always add up to 180 degrees, which is extremely helpful because if you have the interior given, subtract it from 180 to get the exterior and vice versa. Okay. So if I give you all the exterior angles, you can find all the interior angles, just subtract it from 180, and there you have it. Definitely not a regular polygon just looking at it, right? Is there something else I wanted to add here? I think we're good there. These are the ones I gave you on Friday, and you're probably like, why did you make us copy the whole thing? I wasn't sure if I was going to make this, but I ended up making it. So here it is again, right? Formulas where n is the number of sides. And the only thing I'm going to highlight here is that, and I did talk about it, is that ice, those three only work with regular polygons, okay? Those three only work with regular. You're assuming that everything is the same. And I added that, you see this one down here, D, you did not write that down. It calculates the number of diagonals that can be drawn. It might be a bonus question. So just put a star there. So it would tell you, like if you have a pentagon, how many diagonals you could draw inside that shape. And I might talk about it later, okay? But these formulas you should have on your study sheet, okay? It's very important for you to know how to use them. So let's go to page 12. Label ice, so interior, central, exterior, right? Then calculate sized. It's just a way to tell you, find the sum of interior angles, the interior, all the formulas I gave you in the previous page, right? We're going to calculate that for them. And they're all regular polygons. Keep that in mind. Okay, so let's label that. So if you want an interior angle, you pick any corner, and I will call that interior angle like that. Put an I there. The central angle, you got to find the middle as best as you can, then travel to one corner and travel to the other one right here. It's connected, right? Keep in mind that one of the sides here is connecting those two lines. You can't go like over here because then it would be more than a central angle. So that angle right there is what we call the central angle. So you label that with C. Exterior, pick one of the sides and just travel, right? So I pick the bottom here, and I will just travel exactly in the direction I started with, and that is my exterior angle. And you're like, well, why didn't you put it right here, Mr. Dirksen? Why didn't you put it right here? Why, right? You can, right? So I'm going to pick this side and travel out like that. This is also an exterior angle, right? So there are 5 exterior angles, 5 interior angles, right? If you want to do this here, call this I. So you've done that in 2 different corners. You don't need to do that. But here it is. And because my space is limited, I will have to be careful with the way I calculate. So when you do anything with polygons, listen carefully. Figure out how many sides it has right off the bat. So I'm counting 1, 2, 3, 4, 5. It's a pentagon, right? So n is equal to 5. So if I find the sum of a 5-sided shape, that is n minus 2 times 180 degrees, right? So that's really sum of the 5-sided shape will be 3 times 180, that's 540. Done, right? You found the sum of all the interior angles. Okay. Next, I'm going to zoom into that side for now. That's what we're going to say. Interior angle of a 5-sided shape. It starts off exactly the same as before. 5 minus 2 times 180 degrees divided by the number of sides, which is 5. 3 times 180 is 540. Divide that by 5. 540 divided by 5 is 108 degrees. So this is what every single interior angle inside that pentagon is going to measure. They're all 108. And so it would have to be a regular polygon for this to work, right? Because if every angle is 108 inside, it has to be regular. Okay. Central angle. I'm going to do the central here. Central angle of a 5-sided shape is just 360 divided by 5. And so it's going to be 72 degrees. The exterior angle of a 5-sided shape, it happens to be the exact same formula for it as well. Do you notice what the exterior angle and the interior add up to? 108 and 72? It's 180, right? Which I told you all along, right? So it's confirmation, right? D of 5, it's the number of diagonals you can write. And I have to cheat on that one because I forgot already. I think it's, n times n minus 3 divided by 2, which is 5 times 3, no, 5 times 2, that's 10 divided by 2 is 5. And what is 5? Like, what does that mean? I don't want to ruin this pentagon here. I want to leave it exactly the way it is. But if you're interested in knowing what are the diagonals, if you can draw a pentagon, these are the diagonals here. If you were to connect this with this, that's 1, 2. I can't do this because there's a side connecting them. So there will be 2 diagonals right there. Then I go to this corner and I know that I can still connect here. That's 3, 4. And and there's one left, and I don't have a. Just gonna use a green marker or a green highlighter. Right, there's my fifth. So this pentagon, you're able to draw 5 diagonals like that. So that's what you calculate when you use that formula. I might use it for a bonus question. Not exactly like this, but so you know what I'm talking about. This is so dry, I need to drink some water. There we go. Here you go. This triangle, we want to use, not triangle, polygon, we want to do the same thing. Let's label C. So you find the central and just go right and out. So that would be a central angle right there, just one. Okay, and then you want the interior angle, just grab any. I'm just going to grab this one right here and call it I. Travel out of that one like that, and this is E right there. So you've labeled, those are the only ones you can label, by the way. And so let's find the sum of how many sides does this thing have. You count, I count silently, right? So I put a check mark where I start. I count 11. Is that what you counted? Yeah. So sum of 11 would be 11 minus 2. It's n minus 2 times 180 degrees. So it's 9 times 180. That's 1620 degrees. So that would be the sum of all the interior angles. And that number does go up the more sides there are. Okay. The interior angle of an 11-sided shape, I will still use the formula, yeah. So 11 minus 2 times 180 divided by the number of sides. That is really 1620 divided by 11. And this is a decimal number, and that's okay. 147.27 degrees. Let me zoom into that side here. This is, each interior angle would add up to that, okay? Central of a 11-sided would be 360 divided by 11. 32.73 degrees. Exterior, watch this, you have 2 choices. I will show you the first choice, which is 360 divided by 11, which is simply the same thing as before. Or exterior angle would be 180 degrees minus the interior angle. So there are 2 ways of figuring that out if you do know your interior angle. So it's 180 minus 147.27, which is 32.73 degrees. So there are 2 ways of doing that. And the diagonals, that would be n times n minus 3 over 2. That's 11 times 8, which is 88, divided by 2, which is 44 diagonals. Good luck with that. Right? Not missing one. Very hard to do. I'm gonna wait with that with C and D for now. Let's go to the next page there. This chart. On page 13, write down the prefixes. Tri. Let me see here. Don't write it down just yet. I don't know if I have enough cells to do tri and quad. Yeah, I do. Tri, quad, penta, hexa, hepta, octa, nona, deca, and dodeca. Triangles, there would be 3 sides: quad, penta, hexa, hepta, octa, nona, deca, and dodeca is actually 12 sides. So you should be able to recognize the prefix and know how many sides it would have. Okay, this is if you want to put n up here, right? Just 1 second. So this chart I would like you to, for homework, fill this out. Okay, so right, this is your sum of interior angles. That would be your S. This would be your interior angle, exterior angle, and your central angle. Okay, so you use the formulas to fill this in. If you find the interior angle, like I can do this one here, sum of interior angle of a triangle is 180 degrees. The interior angle will be this divided by 3, correct? Because you're just splitting that, so that'd be 60. The exterior angle, I would encourage you to just do this, 180 minus I, right? Which is 180 minus 60, that's 120 degrees. Okay, so these two always add up to 180, right? Interior and the exterior. And then the central angle, right? You can use the formula, or you can just know that the central angle will always be the same as your exterior angle, actually. That's a fact. It has to do with, well, we'll talk about that later. So fill in this, that's part of your fill in. This is just so you have a quick reference to it and you practice that. Can you also go back to page 12 and just say C is homework, and this is homework as well. So C and D, make sure, like, it's not that hard. It's time consuming, yes, but I want you to practice. And D has a little bit of a trick to it. So I hope you see it. It's not a typo. I want to see if you can find it, okay? So 13, you got that, fill that in. And let's go to 14. I know I've covered a lot, but quite a few of that was review. Okay. I'll just do 1 or 2 and then you'll be, yeah. Okay. So working backwards, sometimes you'll be given one of the psyched values Psyched. I don't know. It doesn't really work, but anyways, one of those values, either the sum, the interior, the central, the exterior, or the number of diagonals, that might be a bonus, right? And you'll be asked to determine the number of sides, okay? You are figuring out, hey, what is n? What would n be equal to in this case? Start with the appropriate formula, then isolate for n. That's basically what you need to do there, okay? So when you are given the sum of interior angles, okay, and that is, you should be like, oh yeah, that's S, I know that. S is given, and it's 30, 60, determine the number of sides, right? They're asking you essentially, what is that? You cannot guess, okay? Don't just guess and check. So I start with this. Sum of n number of sides, right, would be n minus 2 times 180. You start with a formula. Just write it out. The 3060 can be actually substituted into that whole thing. Okay, so you substitute 3060 is equal to n minus 2. And here's where it would depend on who teaches you at this point. Some teachers would say, hey, distribute this on this side. And I would say, why? I would just do this. And I'm going to use a different pen, different color. I will divide both sides by 180 first. I want to get rid of that 180 that's multiplying. And I want to make it easier, right? As easy as possible. So that would be step, like, find the formula. Because they gave you the sum, I had to use this formula. I get rid of the 180. And on the other side, you figure out 3060 divided by 180, which is 17. So I say that 17 is equal to n minus 2. That's all you're left with on the right side, so you can get rid of the bracket. Now, this negative 2 here, I'm going to bring that over. So it's 17 plus 2 is equal to n. N is equal to 19. I hope you're comfortable with the variable being on the right side. It's just easier to just bring the other one over. Let me just zoom into that so you have it right there. Okay. So all you need to do there is solve algebraically. This is how you do it algebraically without guessing. Some students guess and check to see if they got it right, you know, and that's fine. I will never know, right? So this is that, yeah. And so the other one, this is going to be the last one that I will be doing with you. I will go straight to C. Straight to C. This is the hardest one. Okay. Maybe you might think this isn't hard, Mr. Dirksen. I can do it in my sleep. Okay. You read and you say a regular polygon has interior angles of 171. So you'll be like, yeah, they're giving me I, right? Calculate the number of sides, right? So n is your question mark there, of course. There are two methods. I'll show you both. Method 1, I have a bias for one of the methods, and I'll tell you that later. But you start with your formula. I, in terms of the number of sides, would be n minus 2 times 180 divided by n. You know this can be substituted. This whole I of n can be substituted with 171. So I go 171 is equal to n minus 2 times 180 over n. And here is where it gets a little tricky. Get rid of this n by multiplying both sides by n. And that allows you to cancel out the n's on the right side. That's what you want. So you're left with 171n is equal to, we can distribute here. So I'm going to use a different color to show you that I did it over here. Yeah, you have to in this case. I distribute the 180 through that bracket, and you end up with 180n, right? 180 times n is this. 180 times negative 2 is negative 360. Okay. And so then I bring the 180n over because I want all the n's on the same side. And it changes sign, as you can tell, is equal to, don't worry about the negative, it's gonna end up working out just fine. 171 minus 180 is negative 9n is equal to negative 360. Here I want to divide both sides by negative 9. N is equal to 40. It has 40 sides. Method 2, my favorite. I will do this because look at how complicated the formula looks like for interior angle. I will say this. Exterior angle of this polygon would be 180 minus 171, correct? I take away the interior angle from 180 to give me the exterior. So exterior angle in this case is 9 degrees. I'm going to underline that because it's important to me. Then I'm going to use this formula. The exterior angle of a polygon is 360 divided by n. And lo and behold, I just figured out that the exterior angle of this polygon I'm talking about is 9 degrees. So you substitute the 9 and replace this whole thing with 9 degrees is equal to 360 degrees over n. What does this look like to you? Cross multiply and divide, correct? So this is my trick. I put the 1 underneath here to make it look like a proportion. You always start on the side where your variable is. You go to the number. You need to cross multiply and then divide. Always cross multiply and divide by what's left over. So n is equal to 360 times 1. It's 360, right? Divided by 9. It's still 40 sides. You choose whichever one you're more comfortable with. I think you should be prepared to show both ways. And hold on. So we're going to stick with our homework on this handout here. At the back of this, I want you to try just this A here, homework. Just try A, and everything else you put homework on. Okay. Thank you, guys. You were great. You're writing down the notes. You're following along.